Welcome to this tutorial for A-level chemistry and AS chemistry, of course, on Kc and chemical equilibrium. In this tutorial, you're going to have a lot of exam questions, and you're going to have to pause the video, try the question yourself, and play only once you've tried it, and then you must mark your questions following my guidance. Make sure you go back and pause and try again and replay, as many times as you need in order to fully understand and learn from these exam questions. And without talking too much, let's start with this 4-mark question. Play when you've tried it. I think it's very helpful to get used to write down, first of all, the Kc, because that's what you're gonna have to calculate. So this is my tip. Always write down the Kc of this equation, because this will help you guiding, your calculations. So in this case, Kc is equal to CH3COO CH3 times H2O. Remember, it's always the products over the concentration of the reactants. Now it's a must that you remember that the square bracket is a concentration. Okay, just keep repeating that in your mind, because you know why? Because it's so easy to forget that. Let's set up the rice table now. Rice, where we have the reaction, okay, which is again this one. I know we're getting a bit too long in writing down, but I think it's very important to have everything nice and clearly structured. Okay, also because look how I'm just setting up now the exercise, because I know what I'm going to have to calculate. Okay, but this is like how I set up everything. And now, okay, what do I know? Oh, we have masses. We have 9.6 grams and 12 grams, and then we have some moles here, which means that the first step is going to be to find the moles of the CH3OH, of course, the MR. Now I'm skipping some steps here because guys, you should know how to find the MR. So it would be 9.6 grams divided by 32, the MR of methanol, which is equal to 0.3 moles. Make sure you write all of your labels nicely, units, we cannot be lazy on that. And then the moles of ethanoic acid is 12 divided by the MR 60 equal to 0.2 moles. Okay, having found that, we can see from the question that it's the student mixes, and then when it reaches equilibrium. Okay, so this is what distinguishes between the initial moles, the I, and the equilibrium. Okay, this is what we need to analyze when we do these Kc calculations. In fact, the methanol is going to be 0.3 moles and then 0.2 moles of the initial. Now, at the beginning, we have no reactants. In this case, sometimes you might have. Okay, and what other information do we have? We have that when the mixture reaches equilibrium, 0.03 moles of methanoic acid remains. So this is where I fill up this box. Sorry, 0.03. Okay, now what do I do now? I'm able to find the change. Okay, so the change, so 0.2 minus 0.03, it's 0.17. So the reactants have decreased by this amount, while the product have increased by 0.17. Notice that the ratio is 1 to 1. That's why the change also follows the ratio. So methanol, we have 0.13 moles at equilibrium and 0.17 for both of this. Okay, now, do I have a concentration? No, because we don't have the volume given, which means that what we can do, we can substitute these values. So 0.03, 0.13, 0.17, and 0.17, because anyway, everything will be divided by the volume, so they would all cancel out. Okay, which if we solve this equation, we are gonna get a value of, and I run out of space, 7.4. This is our value of Kc. And now, very important, the units. Always think about the units. In this case, as I've mentioned about the volumes, they all evenly cancel out. So this Kc has no units. How did you do? Did you get 7.4? Now let's go into the next one. And now a break from calculations. Let's do a 3-mark. Explain your answer. Pause, write your answer, and when you're ready, play. Now we need to be very concise. It's easy to talk too much and not get to right to the point. Okay, so the conditions, we know that it's pressure and temperature, maximum equilibrium yield. Okay, so if we want the maximum equilibrium yield, we want all of the equilibriums to shift to the right hand side. Okay, so what do we know from the equation? We know that it's an exothermic reaction because it has a negative delta H, okay, and that the left-hand side of the equation has more gaseous particles than the right-hand side. So in order to make it, the equilibrium, shifted to the right-hand side in terms of pressure, we know that it's going to need a high pressure because remember that the high pressure would shift the equilibrium to the side with fewer gaseous moles or molecules. Okay, and that's 1 mark. So 1 mark for the condition and 1 mark for the explanation. And then in terms of temperature, we're going to need a low temperature. Low temperature, why? Because remember the forward reaction is exothermic. Okay, and which means that the conditions, to summarize it, we want high pressure and low temperature. 1, 2, 3 mark. Remember to explain it about the favoring of the reaction in terms of temperature and in terms of gaseous moles. Are you ready for the next one? Number 3. The correct answer is, we're looking at catalyst, okay? The rate of the forward and reverse reaction increased by the same amount. Yes, absolutely, because we know that the catalyst lowers the activation energy. So if we look at a diagram where we have like an exothermic reaction, here we have the energy, here we have the progress of the reaction. We have reactants and products. We know that this is delta H and this is the activation energy, okay? What a catalyst does, it lowers the activation energy, okay? So provides an alternative pathway. But forward and backward reaction is changed by exactly the same amount. Then the concentration of the reactants and the products do not change. They don't, because once again, yeah, the equilibrium stays the same. Yeah, it just reaches the equilibrium faster. Yeah, it does not increase. Now, very, very important, remember that the only factor that affects Kc, so is affected by the temperature. Very, very important to have that clear. Let's find the next one. Are you ready for a bit of a more advanced question? So in total here we have, this is 2 marks. Yeah, 2, 3, 4 marks. If you want to pause, maybe take at least 4 minutes to give it a go. This question 5. I am ready for the solution, so make sure that you have tried it. So Kc, as I said, look, even the question tells you to write it down, and you should do it all the time independently. So it would be NO to the power of 2 times by Cl2, typo, this is the product, divided by NOCl to the power of 2. Okay, so in the equilibrium mixture 400, so we have this amount and this amount. Now, think about just even setting up the rice table. Of course, there's no need of calculation here, but you can really imagine it, right? Because what is the relationship between the changes like that we've seen before? It's the ratio. Okay, and when you do calculation, in the back of your mind, there should always be ratio, ratio, ratio. In fact, this is calculated from the equation. From the equation, because it can tell us that the moles of NO, okay, is 2 times the moles of Cl2. Why? Because of the ratio. Either write it like that, or you can write it as, the ratio is 2 to 1. 2 to 1. And next we have this very interesting question. I think you're going to need the value of Kc, and that's it. So off you go. First of all, if you got 1.1, you got the right answer. If not, follow along. So we have the Kc and we have the concentrations. We're going to need to do a bit of rearrangement, okay? So the rearrangement that we're going to do is that the NaCl to the power of 2 is equal to, I bring it to that side, it's going to be equal to the concentration of the reactants divided by Kc. And then, of course, we're going to have to take, to remove the power, the square root of all of this. So, to put in the values, it would be the square root of 0.34 times 0.17 divided by 0.015. And I hope you got the right answer, square root of 1.3 if we solve it, 1.1. Next question, 2 marks. Make sure you write it down exactly for 2 marks. Now, state and explain. Easy to find where the 2 marks are, right? And I hope you noticed that the reaction is endothermic. This means that as the temperature increases, the equilibrium shifts to the right. Why? Because the forward reaction is endothermic. So what is the consequence of the equilibrium concentration? Is that the equilibrium concentration increases. Equilibrium concentration, equilibrium yield, because it goes more towards the product. Now, it's very, very important that you have very, very clear that also the value of Kc will change. Okay, think about it for a moment. Would it increase or decrease if we increase the temperature? It will increase. Why? Because you increase the amount of products. So we had NO and chlorine. So if you increase this amount, then of course also the amount of Kc increases. I hope you understand. It's a very common mistake to think that is not that Kc changes with concentration, but no, Kc value only changes with temperature. And now 4 marks for you. I will give you the solution in as little words as possible, exactly the 4 marks. Again, notice how it's nice and schematic here, temperature and pressure. So what do we say? Let's start with the pressure. With the pressure, we know that the right-hand side, so the right side has fewer gaseous moles. Okay, which means that ammonia, no, let's say that the yield of ammonia increases with high pressure. You can write it in many different ways as long as you have the high pressure and the concept of different number of where there are more moles and less moles. Temperature. The forward reaction is exothermic. So do you remember which temperature favors the exothermic? Low temperature. Okay, that's it. Those are the 4 marks. I mean, if you write it in a nice and structured way, I think it's better. But yeah, remember that there could be some confusion in exothermic, endothermic, and yeah, always mention the keywords correctly. Sometimes you're given a bit weirder question with more complex reactions or, changes in color. Why don't you try these 2 marks? I'm ready to give you the solution. Did you write it down, yours already? So, we add acid. Okay, so the effect of adding an acid means that the concentration of H plus increases, which means that the equilibrium would shift to the right. Why? Because it wants to counteract the change. But with the addition of an alkali, so we have addition of acid and addition of an alkali. What is an alkali? Would be OH minus. What happens? This is tricky. The OH minus would actually react with the H plus, doesn't it? To form water. So what is the effect? The effect is that the concentration of H plus decreases. So what does the equilibrium do? It shifts to replaces that, shifts to the left-hand side to counteract the change. I hope in your answer you put into words my little schemes, but as you can see, this like scribbling, it's very helpful when you need to figure things out. And now it's a very it's also, you know, Le Chatelier principle, but slightly different of how it's worded, because this time we don't have an increased temperature, increase in pressure. You have to figure it out. Are you ready? Here is my solution. If it's compressed by pushing the plunger of the gas syringe, what is the effect? Basically, if it's compressed, you are increasing the pressure. So what is the effect increasing the pressure? It shifts to the side, with less gaseous moles, which means that it shifts to the right. And do you see how we have colors? We must mention that. So the solution turns paler or less brown. Okay. I hope that makes sense. Always mentioning the particles. And the second one, what happens? Warm water bath. Guess what happens? What is the effect? Is increasing in temperature. So you have to interpret the effects that you were given here. So what is the effect? The equilibrium shifts to the left. Why? Because the forward reaction is exothermic. That's it. And now I have a bonus question. This 5 marks. You're going to have to pause, write it on a paper, and send a picture to me personally to mark it for you. Did you save it? Because I have another one for you to try. More advanced calculation for 4 marks. So you're going to have 4 marks to try out and send it to me. Good luck.